In this video we're going to discuss the extreme value theorem, and there's really not much to work through. It's just to kind of explain the concept and what the theorem says. It says if f is a continuous function over a closed interval from a to b, then f will attain an absolute maximum and an absolute minimum at some numbers in between the interval from a to b. Okay. Now notice how a and b they're still closed, which means that the absolute maximum could occur at A or B. So these numbers C and D could be A and B because we are including A and B in that interval where those things will exist. But the idea is that if you just have a continuous function over some interval, that function will take on a very highest y value and a very lowest y value at some point in time in that interval. It could be the same number the whole time, right? So if I had a constant function and it just went straight across, there is an absolute maximum and an absolute minimum. They would be the same number, but they occur everywhere over that interval, right, if that were the case. So in this case, it's very clear to see that f of c is our absolute max and f of d is our absolute min. But the extreme value theorem is just saying that there's guaranteed to be one of each. And then we have Fermat's theorem, which says that if f has a local maximum or minimum at c, and if f prime of c exists, that's important, then f prime of c is equal to 0. So this is kind of what I was mentioning in a previous video, was that if we have a minimum at some number or a maximum at some number, and the derivative does exist there, then what this is saying is f prime of c equals 0. That's saying that you would have a horizontal tangent there. Okay, that's what Fermat's theorem is saying. If you have an absolute maximum or a minimum, and the derivative does exist, then the tangent line there will be horizontal. And that's true for both c and d in this case. An example of this not working is if f prime c does not exist, so something like an absolute value function, if it comes to a point, that means that the derivative does not exist there. So even though it would be a local maximum or a local minimum, depending on which way that V shape went, I couldn't use Fermat's theorem there because the f prime of c exists part was not true.